Hello, Summer 141ers. So this is the first video that I'm going to post to YouTube for you. I want to be very clear from the get-go. This is not a classroom lecture. We only have 5 weeks, and if I were just simply taking classroom lectures, dumping them onto YouTube, and then saying, hey, go watch these, boy, I can't imagine how boring that would be and how big of a burden that would be. It would just be really, really hard to stay engaged in YouTube videos for that long in such a condensed amount of time. So instead, we're looking at trying to meet the same objectives of the 15-week in-class in a different way. And so that relies on you a little bit more to read. You know, if we have in class, you can come to class and I'm going to cover darn near everything in the book, or at the very least, the really, really important things. But in this case, you need to do all of the reading, and then hopefully I'm good enough and have some insight into understanding what the really challenging parts will be, given that you've read and we're engaged in the reading. So that's going to cut back on the time that you have to listen to me, so that's a good thing, trust me. But it does mean that you've got to stay on top of that reading. So I apologize in advance if you get tired of me telling you to make sure that you're doing your reading. So today I want to talk about two things. I want to talk about a change in supply and demand versus a change in quantity supplied or demanded, and then talk about some math. Okay? So number one is assuming that you've read. It's assuming that you understand that economics is about scarcity. It's about how we allocate resources. It's how market systems work. It's assuming that you read chapters 1 through 4. What it will point to is understanding when we look at this market thing together, when we put demand and supply together, understanding some of the terminology and how market dynamics work and the changes in markets so that you don't get confused later on, because I know you're going to love economics, ag economics and otherwise, and you're going to continue on and you're going to be ahead of the curve if you understand, number one, this not so minor detail. So, change in supply and demand versus a change in quantity supplied or demanded. I'm going to erase that and give myself some room now. Now, the law of demand set up this relationship, this inverse or negative relationship between the price of a good and the quantity of the good demanded. And this works for all goods. The strength of the relationship changes, but that downward slope or the inverse relationship is always the same. If everything else stays the same, when the price of something falls, the quantity demanded increases. Demand, the overall relationship, has not changed. Okay? If we're talking about a quantity, whether supply or demand changing, we are talking about the price. If the price changes, the quantity supplied or demanded will change as well, but demand has not changed. So, let's say I just ate at Subway. I think Subway is an example in the book. Subway is not a restaurant that my wife enjoys. It's somewhere I used to eat all the time. Then I got married. I don't eat Subway anymore. That's fine. I've made her life change a lot more, I'm sure. Recently, the price of Subway sandwiches went down. $5 for any footlong, or 2 for 1 or something like that. And so I convinced her to order Subway. When the price fell from $9 per sandwich to $5 per sandwich, this demand curve represents my household demand for Subway. At $9, maybe we eat 3 sandwiches per year. But at $5, maybe it's going to be 10. Nothing else has changed. Now, I understand the reason why the price has changed, and you've got all sorts of crazy stuff going on in the world. But if we're just looking at the price and nothing else is changing, we're viewing a change in quantity, not a change in demand. A change in demand would be the entire curve increasing or decreasing. If we see those shifts forward and back, those are changes in the overall relationship. So as COVID-19 has been an issue that we've been dealing with, what's happened to demand for most restaurant food? It's come back. People say, gosh, you know what? Turns out all of that food that I used to go out and buy isn't that good, and I want to stay home and not get coronavirus, perhaps. That's a change in demand. And if you look at what happens when the entire curve changes, it doesn't matter what the price is, the quantity demanded at all of those price levels has changed. So if this is Subway, and demand for Subway is decreased, the quantity demanded at $9 decreased, the quantity demanded at $5 decreased as well. Something fundamentally has changed the way that we view Subway or whatever that market is. Okay? So let's recap. If the price changes and nothing else changes, the quantity will change. The curve doesn't shift. If something causes demand, the entire demand curve to increase or decrease because something outside of demand that affects that market has changed, then we say demand changed. And the same thing goes for supply. Okay, that's number one. Number two, is about quantifying demand and supply and then markets. And that's what your assignment is about this week. So let's say that we're looking at demand for pickup trucks. We say that demand is equal to 50,000 minus 2 QD. So I have this demand curve that's represented by a line. We can put this demand curve on the graph, and I know that 50,000 is here. That's the p-intercept. It would be the y-intercept in math class, except now our p's are y's and q's are x's or q's, and they mean something. And in this case, what it's really saying is $50,000 is where demand for trucks becomes positive. Maybe this number is a little bit low, that's fine. So this is saying, hey, the highest price that anyone is willing to pay for a truck is $50,000. And the relationship between price and quantity is a 2-to-1 relationship. That's what this -2 means. If we put in a price of $49,998 and we solve for Q, Q equals 1. Now, practically, we can usually say, hey, demand becomes positive at this $50,000. But in this case, when the whole first truck is demanded, is if the price is $49,998. And the reason why I knew that is because I recognize that too means that for the quantity to increase by 1, the price has to fall by $2. So this demand curve, it gives us the opportunity to say, well, I wonder what would happen if the price were $30,000. Now, this is not looking at the market, it's just understanding what behavior would be. If the price were $30,000, well, what would the quantity demanded be? Well, we just plug 30,000 in for P. 30,000 is equal to 50,000 minus 2Q. So negative 20,000 is equal to negative 2Q. And I know I go too fast sometimes. So all I'm doing is I've got 30,000 in for P. I've said I'm defining this P. Plug it in and spit out what that quantity is. Tell me what it is, demand curve. So I put in 30,000 for P. I subtracted 50,000 from both sides. So I'm 30,000 minus 50,000 is negative 20,000. Negative 20,000 is equal to negative 2Q. Divide both sides by negative 2. And I get Q is equal to 10,000 trucks. Good. You know, we probably could have thought about that, knowing this 2-to-1 relationship. Hey, the price fell $20,000. That's going to increase our quantity demanded from 0 to 10,000, or 20,000 divided by 2. Okay? So you can think about the demand curve as just a series of P and Q coordinates that are attached by a line. And we make it linear. It's not exactly right, but it's okay. I'd rather do this than calculus. We'll save that for your intermediate micro class. But for now, we're going to assume straight lines, and the world will be a little bit simpler. Okay? So that's how we interpret a demand curve from the mathematical sense. Okay. Now let's say, however, didn't want to erase all of that, that I have a supply curve, and my supply curve is equal to 10,000 plus let's make it 3QS. Okay. So there's my supply curve, and my market clears at a price where the quantity supplied is equal to the quantity demanded. And this is where the magic of markets comes into play. And I can't help myself but talking about it. I know it's in the reading. Why does this price that we haven't solved for yet emerge? And the reason why that price emerges is because if the price is too high, so up here, the quantity supplied is greater than the quantity demanded. And whether it's trucks or corn or livestock or anything else, if the price is too high and it's not selling, firms have only one choice: lower the price. And if the opposite happens, that the price PL is too low, what happens? They sell out so fast. And they say, you know what? We sold out really fast, there's a shortage. You bump up the price. And they do that. That's pretty easy to imagine. Okay? So, let's solve this. Okay. I have two equations and two unknowns. P is equal to P, so the left side is equal. So if we take the right sides, say the left sides are equal, if P is equal to P, I'm going to force the right sides to do the same. So 50,000 minus 2Q, and notice I dropped the subscript because this quantity that I'm solving for, quantity supplied is equal to quantity demanded. Trucks are trucks, whether we're supplying them or demanding them, so the subscript can go away. 50,000 minus 2Q is equal to 10,000 plus 3Q. Let's add 2Q to both sides. 50,000 is equal to 10,000 plus 5Q. Let's subtract 10,000 from both sides. 40,000 is equal to 5Q. Let's divide both sides by 5. My quantity is 8,000 trucks. So let's clean this up just a little bit. Bob Ross, I am not. At 8,000, the corresponding price can be found by putting 8,000 back into demand or back into supply, and we should get the same answer. 50,000 minus 2 times 8,000, 50,000 minus 16,000 is $34,000. They must be small pickups. 10,000 plus 3 times 8,000, 10,000 plus 24,000 is also $34,000. So our market clearing price is $34,000. Our market clearing quantity is $8,000. If you were posed with a question, demand increases to 60,000 minus 2Q, the demand curve shifts this way, we can see that our new equilibrium price and quantity will go up. That's well spelled out in your reading, so I'll leave that up to you. Don't let the math in this class get in your way of success. This is it. I mean, this is really about as hard as it gets. If that's a problem for you, speak up, okay? We all have strengths and weaknesses, and if math isn't your weakness, you can still be, if math is your weakness, you can still be a good economist, okay? Summer would be a great time. We can brush up on some of those things. So ask me, ask anyone. Let's get through it, okay? So that's enough for today. I'll see some of you in a few minutes. We're going to have a meet and greet today. I hope you enjoy that, and then we'll be full speed ahead for the next 5 weeks.